var mycket folk här. Då kör vi igång. Welcome everyone here, and welcome all people in the audience. It was a surprisingly large number of people already connected. And great to see so many here. We were really planning to have like a normal in real life meetup for this discussion, but you all know the circumstances around this, so we try to make the best of this situation. I'm going to try with this new software called Big Marker to have an as interactive webcast as we can. And I really want this to be as interactive as possible. So please do take the time to just use the chat window or the question answering functionality here to ask any question at any time. And I will try to interrupt people and get as many answers answered as possible. And we're also going to try some kind of poll functionality and see how that works. But let's start with an initial poll and see if this works to get you all started with this software. So the first question is, have you ever heard about the Swedish language models for Swedish authorities project before? So please just answer yes or no. And we're starting to see some answers getting in. Nice. Seems like a lot of people actually have heard about it. Great. And we're going to hear much more about it. And let's start with a quick round of introductions first. And perhaps we can start with you, Daniel. Who are you? And can you please just tell us your name and what you do at Vinnova and how it's connected to this project?
Yes. Hello, everyone. Daniel Renkrans from Sweden's innovation agency, Vinnova, where I'm head of department for innovation management. And I'm also coordinating all our initiatives on artificial intelligence, where this project resides.
Thank you. And Love?
Yes, my name is Love Börjesson. I'm director of KB Lab, which is the data lab at the National Library of Sweden. And it's also, so it's an infrastructure for research in digital humanities and digital social sciences. And it's also a resource for the library within artificial intelligence.
Right. And then we have Sebastian from Peltarion as well.
Yeah, so I'm Sebastian. I've been at Peltarion since last year, and I've been doing some digging into how we can use multilingual models in the context of this Swedish language model project.
Also a big fan of Gaussian processes, I've heard.
Yeah, absolutely. Everything Bayesian. Go Bayesians. We're all Bayesians out there.
We also have John here.
So my name is John. I'm an AI research engineer here at Peltarion. I've been here for 2 weeks longer than Sebastian. Working a lot with natural language processing, both in industrial applications, but also in this research project, where we've been looking a lot at applying multilingual models to Swedish.
Great, and I can just quickly introduce myself. My name is Anders Arpteg, and I've been working with AI for like 20 years. Did a PhD back in Linköping 20 years ago. Know Daniel and others from a long way back. Now heading up a research group that we have here in Peltarion, where we have a number of initiatives. One is this Swedish language model project, but we also have a number of other ones working with medical use cases and with music, audio, text, and whatnot. But text is certainly one of the focus areas we have. So with that, I think we should quickly proceed with the first presentation. So we're going to have Daniel present from John's computer. So it will look like John is talking, but in reality, you will see Daniel's face and see his presentation from his computer. So with that, I hand it over to Daniel.
Yes, very good. First question that will come after this short introduction. Kermit? And who's this? No?
The Cookie Monster, no?
Cookie Monster?
No.
Anyone? And Mr. Chat, if you know. It's Rosita.
Ah.
And this one, Grover, Big Bird, Ernie, Elmo, and Bird. So the question is then, who's missing?
Oh.
And what's the relevance of this question to this webinar? If you have to know the answer, just write in the chat. Anders, any
I'm trying to recall the Sesame Street names or profiles here, but I'm drawing a blank, I think.
Anyone around the table?
The Swedish chef.
The Swedish chef. Yes, all of these are names of language models.
Mm.
Well,
We got
what's
Miss Piggy as well from the audience there.
yeah, Miss Piggy. Oh, good. Yeah, it's right there from Philip. Is using these for modeling NLP. These are NLP models, and what is frequently missing is the Swedish touch.
Mm.
All of them works very well in English, but what about in Swedish? And that's why we are here today. But before we start to dig into that, let's give you the broader picture when we're talking about AI and Sweden. Everyone knows that computational power is something that has enabled natural language processing. Looking at Sweden today and the state of computational power in the world is not looking that good, really. On your left-hand side, you can see this number of supercomputers in the world from the top 500 list. And if you look at this chart and compare to the work that has been done by WASP, you can see that Swedish computational powers is decreasing. And also what is not being shown in this chart is that this is for academia if you look on the Swedish figures, but if you look on the right-hand side, where is the real power being driven with respect to computational power? It's in industry and in application. So this is not looking that good, really, that we have a old architecture with respect to computational power, but it's something that's very important if we're talking about research and innovation. It's one thing if we talk about buying something off the shelf, but if we're talking proof of concept and so forth, it's very important for small and medium-sized companies in particular. Obviously, one important part is to look at research. Here we can see down at the bottom where Sweden is. And obviously, if you look at figures, United States and China is dominating. But behind the figures, what is very interesting is that countries such as Korea, they are increasing rapidly in this race. It's one thing to look at the actual number of publications, but what about if you take per capita, for example, into consideration? Sweden is a small country, so taking that into consideration, it looks slightly better. But what about quality? Number of publications doesn't really say anything about quality. So let's look at the top 25% of publications in the field of AI. Well, that gives you a different perspective.
How is this actually measured?
It's measured with respect to impact on publications. So you look at the number of publications, first of all, what is published in journals. And then when you look at how much are they being referenced by others? Yeah. So that's the top 25%. And if you start to dig into these figures, you can see that, for example, third from the left is United States, but then if you go down to top 10%, for example, and you look what are the key research players in this field, then you start to see not only, for example, MIT and Stanford, but also the American big firms. They're really driving this field. And Sweden do have some researchers that are very good. Obviously, a problem when you look at this is that it's easy to capture those that are in computer science and AI research. But some of the most prominent Swedish researchers, like Amy Lufti, she's not publishing that much in those journals, but rather in journals that are application-oriented. So this is sort of like a problem, but still it gives us a hint of what is our position here. We can also look at what is the trends in AI research today. On the left, you see the growth rates where you have artificial neural networks that are increasing a lot. Obviously, if you take the absolute number on your right, you can see there's still machine learning that is really driving in this.
So if I may interrupt, we got a question about where is China?
China, That's quite interesting if you look at China. China is often figuring when you're looking at number of publications, but if you look at quality, top 10%, for example, they are starting to appear there, but it's still a lot about frequency, a lot of publications, but not having the big impact in the journal system. It's starting to change though. So if you are looking at the early 2010, for example, they're barely on the chart, but nowadays they are getting up there to the top 10%. So it is changing. We can also look at other, sort of like Gartner, for example, their hype curve. What can we see here is and this is for natural language processing, what is being expected from 2019. And you can see that obviously a lot of things that are progressing here, but in terms of natural language processing, is still in the development. You can see that there's obviously chatbots and so forth that are being produced, but in terms of generalizability and scalability, there's still a lot of things to do, and that's why it's high on the hyper curve here. And what is perhaps problematic if we're looking at the Swedish discussion now, where there's so much discussion about chatbots, when in reality it's not really fitting to what the actual needs of organizations are. It's easy to take that off the shelf and try to implement it, but in reality there's two problems. One is the technology maturity, but the other one is, does it really correspond to your actual needs? We do have some problems with the slides here, but one thing to bear in mind here when we're stepping into not just general AI, but into the field of natural language processing, is to keep the societal perspective into mind. For example, on your top here, you can see a calculation done by American researchers. How much energy does the training for the big natural language processing models, how much do they consume? And then they compare this, for example, to a US car, the average lifetime consumption, CO2 consumption, you can see it's 5 times as much for training one of these big NLP models. So we do have societal challenges here where we're purely driven by big data lakes and so forth. And on your bottom, you can see just a journal article that has made clear the problems when we're using off-the-shelf models is that they are including a lot of bias as well, even those coming from Amazon and Google. So we need to be aware of here that natural language processing is something very good, but it's not without problems. The question then is, if this is the backdrop with research and so forth, what is the state of AI in Sweden? 2 years ago, Vinnova launched an AI report on the state of affairs. And what you see here is sort of like the overall conclusions from that, is that we do have a lot of good things here in terms of general digitalization, a good education system and so forth. But when it comes to field of AI, we're lagging. And things have progressed since 2018, but bear in mind, so has the rest of the world as well. So it's sort of like standing in an elevator that's moving down and you're trying to get up. You're standing still or moving slowly, you're actually not progressing at all. You're losing ground. And one example of that is from the review of OECD when they looked at Sweden. They saw that the things that are very important for AI, such as big data, we're lagging behind. Data readiness, open data, and so forth. There are countries that are much more progressive. So even though the general prerequisites are there, we're still lagging behind. The good thing, though, is that even though we have had a late start, we are perhaps a small country. We are a dynamic economy where we have all the bits and pieces there to make a difference with things that are hard to measure in indexes, such as collaboration, ecosystems, and so forth. Everyone knows that that is very important, but it's hard to measure, and it's something that we can have a competitive edge. So, with respect to this backdrop, 2 years ago, I was given the assignment to basically answer the question, what should Vinnova do? What is the strategic direction that Sweden must take? Or put differently, what difference can Vinnova make?
And what is really the mission of Vinnova in general, you would say?
Enable innovation that makes a difference. Things that wouldn't happen otherwise. There's a lot of innovation going on that will happen with or without Vinnova. Typically, things that are between boundaries, organizational boundaries, sector boundaries, boundaries between research and production, for example. So those kind of things, and where the risk is too high for an individual organization to manage themselves. One example of that is what we saw is that there's a lot of good initiatives in Sweden. We counted easily to 40 AI milieus in Sweden. Most of them typically quite small, typically very regional, very good in themselves, but not bringing a competitive edge for us as a country. So we saw that we need to have an initiative, an ecosystem initiative that accelerates this research into innovation and that bridges the regional capacity into a national competitive advantage, so we can have an international impact. Because in AI, it's very much you're either on the international stage, or it must be something that is so important for the country itself, so we must invest anyway, but you must always have that international aspiration. So what we saw was that there's so much going on within the business to consumer and so forth. But what about AI for good? What about societal outcomes? Things that are not, taking care of themselves. So we saw three areas. One was data and infrastructure. There's a lot of data out there, but if it's not being used, it's not of value. But how can we enable that in a good manner? Not just having it open, but enable that. So then we have funded data labs, and I'll give you an example later on that. So there's a question here from the audience. Are there comparable EU programs like AI Innovation for Sweden? I have seen some very good initiatives around the world. Mila in Canada is an excellent example. They are world-class in machine learning, for example. There are some good initiatives in France and so forth, but not really what I've seen that is, apart from Canada, that is really taking an ecosystem perspective.
What do you think about the new EU Commission initiatives, like the White Book and potentially the data spaces from the data strategies, etc.? Do you see any connection to AI innovation of Sweden and trying to build up ecosystems like in all of Europe in some way?
If you start from a national perspective, I think that initiatives such as AI Innovation of Sweden is critical if you want to be able to compete for that money, basically. Yeah. We're too small and too fragmented otherwise. So that's something that's very important. The problem that I see with the EU initiatives is that on the one hand, we don't want to take the route that China is doing with no real sense of integrity, personal integrity, or the American way that, it's market driven. If it crashes, then we fix it. The problem though with the European approach, or the challenge, is how can we have an ethical approach, or whatever you want to call it, but do that in an iterative and progressive manner. Because I see that there's a problem is that it's sort of like a wet blanket over innovation and development now. There's so many companies that are not daring to do tests in practical environments, for example. We have had projects now in retail tech, for example, where they have used law firms that are very good, had a professional opinion that this is in compliance with GDPR, but they can't get around the data inspection, for example. So there's so much here that is big, but we don't want to let it completely loose. But I think that we can play a role there by being, balance those approaches.
So Sonia continuing with like a non-pan-European level, and perhaps to not stay too long on that, but I know it, for example, Finland already did some kind of national strategy in 2017. Then in 2018, we saw a number of them from France and Germany and also Great Britain. But I don't think it's the same type of same level of initiative as AI innovation in Sweden, I would say.
No, I haven't seen, no. What other countries do have, such as Finland, is that they have more top-down with respect to visions and things like that, where Swedish approach is more bottom-up. And that's why, for a Swedish context, this kind of initiative is so important to bring actors together. What we have also put money into building innovation capabilities. For example, our review manifested that there's so many public actors, as well as existing small and medium-sized enterprises, that don't use AI, even though they would gain a competitive advantage using that. So that's why we have had 2 calls on Start Your AI Journey, for example. So it's very important that we build capability in this area. The third pillar is that we do have now with WASP, for example, a lot of good research coming out, but how can we get that into application, into implementation? So there we have seen the importance of accelerating that. And for 2019 and onwards, one of the key strategic themes that we have identified is natural language processing. Because what we see on the international stage is very well taken care of in English, but what about Swedish? And in particular for the public sector, where the language quite often is not what you call common Swedish. So that's one thing. And now we're also working with climate, AI for better climate. So that's the recent launch that we're doing together with the Research Council Formas. And what we see, and the importance of accelerating this, is that there are so many practical utilities where you can see that AI can fulfill and meet strategic demands in the public sector. Some examples is, which is part of this project, the Swedish Public Employment Service, not just working on analyzing trends in the job market, but also how they can use that to better match people that are seeking work with those that can offer work. It's one example. Försäkringskassan, the Swedish Social Insurance Administration. This is a very interesting case. What they saw that with digitalization and with, for example, solutions such as BankID, they had about 1,100 cases of answering in the phone, taking easy questions and so forth. And what happened with this digitalization was that it really dropped. The number of calls to these 1,100 cases really dropped, but the questions that came in were very tricky, very hard. So they reorganized and had to, change the management and reskilling and so forth. But what they're looking at now is that when these tricky calls come in, how can we use AI and NLP to give suggestions as these are the questions that you should ask really. These are the key documents that you could look into during this call, and obviously it's transcribed as you're talking with the customer. And what they have seen is that it's quite tricky because these kind of open models and tools that's being developed in this project needs to be available on the market. Obviously, there's solutions they can buy from vendors and so forth, but it costs a lot of money and you might not really be there. You need to start experimenting and so forth.
Cool. Yes, we got some more questions here. If we have time, we would like to try to have like 30 minutes per speaker, and we'll see if we manage to do that. But, do you want to take this question as well? Is there a relationship between academia research and the increase and decrease in industrial AI development in the country?
Oh, that's a difficult question.
I can give my quick review on that,
yeah,
at least.
Go ahead.
But at least, you can see in US and China that the industry is really leading the AI development work. It's the big tech giants, it's the Google, Facebook, Amazon, Microsoft of the world, and Alibaba, Baidu, and others, and Tencent, etc. in China, that is really driving and leading the AI research and development right now. And most other companies is not at all at that level. And academia is even falling behind, and they're basically having a brain drain right now from academia into industry, at least in those countries. And that's something we have to think about, at least.
And that's something that differs slightly if you compare Europe to China and US, that we don't have these big firms with heavy R&D.
Yeah.
Another example is National Financial Management Authority. Did you know that as many as 100,000 pages are being produced every year, approximately, with different investigations called SOUs, the state governmental investigations. But how many of them are being read? Are we taking care of the knowledge there? And you can use AI in that field as well, so draw out different patterns there, for example. Swedish Language Data Lab, which is sort of like connected to this project, is that we need to institutionalize the work that is being done, for example, with respect to data, and we will hear from National Library, very important example as well. Before I wrap up, what is the elephant in the room with respect to my speech then? Any ideas around the table here? What should I be talking about here if we talk about NLP and the public sector that I haven't talked about at all, really? Any ideas?
Surveillance states, Big Brother states.
We can talk about that, very important, but
typically comes up.
But we haven't spoken about the language model projects.
No, I haven't. I'll come to that. But Vinnova, I haven't talked. What is Vinnova doing?
Okay.
So, well, afterwards, we're putting the fingers on other public sectors. We need to work more on this. I see that fraud detection is coming out. There's obviously a lot of things that I haven't talked about. But what about Vinnova? What can a small agency do in this field? Well, 3 years ago, I think it was, that we did our first pilot. Then it was a problem with respect to the data warehouse that we had, the architecture. There was also a problem with the tools available in the market and the maturity level within the organization. But now we're much better in a position to do something. So what we're doing now is to see how we fund about 2,000-3,000 projects every year, and obviously we don't accept every application. So we have a lot of applications, even though they are not very standardized. But so therefore, how can we use AI here? So we see that then we can understand our portfolio better. We can, for example, follow trends more easily and detect trends. Can we, for example, compare our portfolio of application with Google Trends, for example? It would be quite interesting to see what is moving out there and what do we see in our portfolio. And obviously, with respect to collaboration with our research funders and so forth. So what we have done is to use AI on innovative startups. Is one call, and what we saw there was that we detected categories of applications that we could not see with our predefined categories. So that's quite interesting. So that's one example. And further down the lane, we think that we can use this to actually map the application to what reviewers should look at this application, for example. So we're doing this now, and this is just the version that is being currently done on 800 applications now in the startup call. So you can see that we can detect topics here that are not easily defined beforehand, which will also differ from one call to another.
Interesting.
So what we see, and obviously I think that the public sector in general see, there's two important problems here where we can see a direct link to this project that is so important to deal with. One is the maturity level. If you look at BERT, for example, you could probably say there's TRL, technology readiness level 7 or 8, depending on the application that you're talking about. If you're looking at the Swedish equivalence, it's very much immature. So we need to raise that maturity level with respect to open available models. And the other one that I see is that there's a lack of tests for benchmarks. If you develop your own models, for example, we have used Wikipedia data for the first generation, and second, we used the National Library and their data. But how do you know that your model is good? I think that these are two very important problems that we need to all work on, and that's being addressed in this project. There's at least 140 billion reasons why we need to solve them. Obviously, NLP is not connected to all of them, but when the governmental agency Digital Government, they did their review recently of the state of affairs in the public sector, they saw that you could at least save 140 billion crowns annually in the public sector by using existing AI technology. And even though they're not specifically targeting NLP, I see that it comes into it heavily.
Awesome. I wish we had that the time we have today with Corona and everything, and the big load that we are causing all the public agencies we have.
Yes.
Perhaps in the future, at least.
Exactly. So that's sort of like the backdrop to why do we fund this project? Why it's so immensely important.
Awesome. In interest of time, perhaps we can have more questions later for you as well. And if anyone listening to this have a question, feel free to add it to the Q&A section or to the chat that we have. But let's try to move forward unless we have some direct questions. I don't think we have. So let's directly move over to Love and hear more about what the Royal Library is doing.
Yes, the National Library.
National Library, sorry.
Yes, it's not the Royal Library per se. That's just the old name in Swedish. Doesn't really matter. Anyhow, so thank you for inviting me. It's very nice to be here. So the Data Lab at the National Library of Sweden is a infrastructure for research, digital humanities and digital social sciences. And part of the infrastructure is, most importantly, it's data. So the National Library has a lot of digitized data. The library is a data hoarder. We have collections that stretches over 1,000 years back in time, and they are growing constantly. When it comes to text, there's no match when it comes to Swedish text data, really, and the same for audiovisual material. So we have lots of data. That data has been inaccessible for researchers previously. So that's why the library decided we should have a lab to allow researchers to sort of work with this data in a structured, quantitative way. So the data lab is very new. We started up in June. And the infrastructure is, so it's on-premises unlimited access to data. It's computational resources, because typically our data is copyright protected, so it needs to be analyzed on-premises. To do that, we need to have computational resources. We also have that. And
for the more technically oriented people in the audience, including myself,
Yep.
can you mention some technical details about the computational resources you have?
Yeah, so when we started up, we wanted the researchers to have sort of maximum freedom. So we didn't want to have the typical server solution with, very thin clients accessing a server, but we want, because at my lab at Stanford, we had that, and since I was in social science, we were always sort of the last to be given access to the service, because the medical research was always prioritized before us. So
Yeah.
very traumatic experience there. So I didn't want to have that on the lab. So we have working stations that works as
With
clients.
GPUs and
Say again?
with GPUs and whatnot?
Yes. So, and we have differentiated a little. So we have the fastest we have is 248 GPUs right now, 48 gigabytes. So it's an okay computational sort of power in those computers. And we're building now, but it's very hard because all our servers are stuck in China. So, but the next stage in the technical infrastructure, it will be more traditional with a proper server, and you can access that somehow. So, and when it comes to software environment, we want the research to be able to control that. So we have basically, as long as it's Linux based, you can have whatever you want. Surprisingly, many are, I was about to say stuck in R, but they like to use R, which is the big sort of language for social scientists and humanities. We're trying to push them to use other languages as well. That is more apt for really large data sets. And then we started when the first BERT multilingual came in 2018, right? So we started to use that quite immediately, the multilingual model, to classify doctoral dissertation abstracts, which there's a nice bilingual corpus, which is called SvedPub, which is all Swedish abstracts for Swedish doctoral thesis, and they're typically available both in English and in Swedish. And we saw that the language model performed very, very well, and we also saw that using the model, we could identify weaknesses in the classification system. So when there was ambiguous, in the confusion matrix, we saw, okay, so here we get some classification, yes. And when we brought those abstracts up, we couldn't see the difference ourselves. So the model was sort of on par with the human reading of these abstracts. So, okay, this is a great language model. We can use it to classify, but we can also use it to enhance the classification schemes, etc., which is a huge thing for a library, right? That's what we do all the time. We classify stuff. So we decided then we should have a language model of our own. And an additional reason for that is that Google Multilingual, the Swedish data is the Swedish Wikipedia, which is very large, but still it's just Wikipedia. It's just one type of Swedish and not that much Swedish. So we wanted to use our resources of digitized data, which is digitized newspapers, is the governmental issued investigations, SOUer. We have social media, what we call him and her, which is Flashback and Familjeliv. Two big platforms which are sort of pretty much like Reddit, if you don't know what. And then we have some monographs, which is for the normal person is novels, and there are some additional data that I'm forgetting right now, but still, we have a lot of data.
For people that don't know how the National Library works, I mean, it's not just the books you have in the actual physical libraries, but you basically get all the different articles published sent to you, right?
Yes, there's something called the deposit laws that has been in place since mid-17th century, so for a few hundred years. If you publish something in Sweden, you have to send it to the library, and we store it, and we never delete anything. So as soon as it's in our collections, we keep it forever and ever and ever. So we have very vast collections of everything printed in Sweden, basically.
Do you have any numbers in terms of articles or size?
I think the digitized newspaper collection, for example, I think it's about 15 billion words or so. And we're working backwards to sort of to cover everything. And we also have, which is very cool, we have a project with the Royal Institute of Technology for speech to text for our news broadcast, etc., which is 15 million hours or so. So then we will have a large spoken corpus as well that we will put into the model. So we have been training the models during the autumn, different models, a BERT base and a BERT large, and the Albert, etc. And we find that the Albert is much harder to train, so that will not be finished for some time. We have an alpha version that doesn't really perform that well. But we have two really good BERT, the BERT base, and which performs very well. We haven't done anything to the architecture, to the model. We just, plain vanilla, but it performs very well. And then we have the BERT large, which we think will perform even better. It will be released in a couple of weeks on our GitHub account. All models are open. That's the good thing about them. Since they don't really contain text, only words and language understanding, we can release them to the public domain.
So you don't have to take care of anonymizing any data set before you use them for training?
When it comes to names, typically no. When it comes to personal number, like social security number and the like, anything that looks like a number like that, we take them away. Also, when we used Flashback, which has some threads in it that are not very nice, for example, we have contemporary crimes where people put out the investigations, for example. So those threads are, we move them out of the model. We can't really release that into the public. But otherwise than that, they're fairly uncomplicated. We don't see it's a big GDPR problem. The names are sort of torn apart, and there are statistical associations though. So, when we try our model, we have built some downstream. We can't really test the models. We can test the next sentence prediction, of course, and it's they perform very well, and they perform better than anything else that is made that we know of in Sweden. But we want to have, as you mentioned, Daniel, there is a lack of test beds. You can't really test the models. But when we test downstream models, like we have a named entity recognition model, for example, it's brilliant. It really works very, very well. When we also tested it on texts that are very alien to the text that we train the model on. So we have tried our named entity recognition model on text from mid 17th century, so text from 1628 or something, and surprisingly, it performs very well. It finds almost all entities in there, which I think is mainly an effect of the robustness of the model, which is an effect of that we have many different types of Swedish in there.
So we had one question, perhaps you can answer, about if you have anything besides textual data.
Yeah, so we have all the visual collections. The deposit laws are since '79, also covering everything that is broadcasted, so like audio, television, etc. So yes, we have. We're swimming around in data.
And I guess all the images you have in articles is also stored somehow.
Yeah. So the newspaper archives are not just text; it's actual newspapers, and then we can extract images and text, etc. from those.
I had another small question that we may have time for, more technical one. How many entity groups do you try to classify into?
So we had names, so persons, organization, places, time, objects. What am I forgetting?
If it's product names or something.
Yeah. So it was pretty basic. But it should be an easy task to sort of. But what we're working with right now, and we're working together with RISE, for example, we want to build we think that building a Scandinavian model will be beneficial to all the Scandinavian languages, because we could investigate the cross-language signals, but we also think that it will perform better on the individual languages. But before we do that, we want to use this sort of expertise in RISE and NLP group that is led by Magnus Sagan. to adjust the architecture also before we do that. And there are, as you all are aware of, there are bottlenecks here. Now I'm talking to you, so you have the money. There's data, we can solve that, we have the data. The other one is computational power, or computational resources, which is a huge thing actually. And then it's test beds. So these are the sort of three bottlenecks that I see. And data, we can solve that, but in order to sort of be able to use our data, we need to have computational resources as well. So there's a problem. So right now, what we're working with is to work with the copyright holders to be able to move the data around so we can, for example, use the Tensor Research Cloud to train them. Yeah, for example. Someone who has the Tensor processing units. We would cut the time, and it would be like, well, going from 90 days to maybe 6 or 7 hours or something like that. And that would, of course, be very beneficial. For example, when we develop models together with RISE, they are part of this NLP project to have language models for Swedish authorities. They don't want the models to be biased naturally, because if you have a model for Swedish unemployment, what are they called? Agency. Yeah. You don't want the statistical sort of association between certain names and certain jobs, for example. It's probably gender biased, not probably, most certainly, etc., etc. And same thing for the police. If they're using our models, they don't want to have this sort of, and the murder is, so there's a problem there, and somehow this bias need to be addressed. Either that you have some model after that sort of take care of the bias and corrects it, or that you can think about the data you put into the model, etc., etc., etc. We have another sort of beneficiary in the end, which are researchers, and they are typically interested in biases, so we can take it away from the model. So we have different angles. So when we're training a Scandinavian model together with RISE, we would actually like to try to train 2 models. And we don't really have the time or resources to do that on the lab, so we want to do that in the cloud somehow. So.
We have time for a small question here. So Sonia is asking if we have any corona-related text collection going on right now.
Yes, so we are collecting social media. We sort of pressed record.
Oh, okay, right. So everything connected in some way to some corona-related tags.
Yes.
We also, I guess, have the White House data set that was released recently with a lot of different sources for corona-related text that could be interesting.
Yeah, so one of the early warnings about corona came from a Canadian company, I think, that used some kind of algorithm. It wasn't BERT, but it was some kind of language. It was informed by the NLP somehow. Yeah. I haven't looked into it, but so I think we could do better than that algorithm probably, since we have better language models now. So.
And that's something very interesting, isn't it? Can we use this experience to build capacity to work with forthcoming crises, so we are better equipped the next time, rather than reacting?
Yeah, and I guess after the corona crisis, we'll have so much data as well that we can basically back test it and see, what model would have actually worked if you've used them in the past to do this properly.
So we see, for example, that the governmental information campaigns around corona is largely working quite well, but in some areas in Sweden, especially some suburbs in Stockholm, it does not work at all very well. So.
And I can just mention the company you mentioned was called Blue Dot, and they used basically a news article to try to detect if an outbreak is going on. And I think they also used like flight plane information to try to track the spread of the virus, so they can understand how it's going to spread around the world and stuff like that. So interesting stuff.
Interesting stuff, yes. No, so now we're working with, so we're trying to be able to work with the copyright holders, and I think they have been very constructive so far to be able to, because it doesn't really threat their rights to the copyrights for us to put the data into cloud and build models and then take the data back. It doesn't really, no one else can access the data. So I think we will get there. The other big thing is, of course, that we want to provide access for researchers to access our data through some kind of server tunnel or a Docker solution. So you can do stuff with the data while it's still at the lab, but you don't have to be at the lab. The technical solutions are all there, but there are legal stuff that has to be dealt with.
Yeah, we know all about that at Peltarion as well, I can tell you.
Yeah.
So it's great to hear that you're at least trying to make it available, even if it's on.
Oh, we will get there. We will. But yeah. And from the library perspective, the more people, researchers, etc., that are using our data, the better, because that's when the collections has value, when they are in use, so to say. So.
Perhaps one question, and thank Philippe for the suggestion of BERT-Gen. It would be interesting to look into. But it would be interesting to hear also potential use cases that you have used or could use BERT for. So you mentioned the classification part. I guess you have your hand-coded categories that you want to categorize doctoral abstracts into.
Yeah. So it's called metadata in the sort of context of libraries. We have metadata, different metadata schemes. We have Dewey. We have the Swedish library scheme. We have, there are several different. We have UKÄ. What's that? The authority for higher education. Their classification system.
Oh.
Universitetskanslerådet, but they have changed name now, right? It doesn't really matter. Anyhow, so there are several of those, and typically they are they sort of take as the starting point the education of librarians and the needs of librarians, and that is not super interesting for the lab because we are more interested in other uses, researchers, etc. And common users. What are they interested in? And they're typically not so interested in our metadata coding schemes. They're interested in other stuff. So can we use these language models to have a different way of working with metadata? Yes. So first of all, we can of course have some kind of rationalization of how we classify stuff. That's the most obvious part, not so fun part. The more interesting thing is can we enrich metadata using language models? And yes, we can. For example, we can use language models to extract entities, and then we can link the entities to various resources, for example, Wikipedia or our own library catalog. So when we have the book, well, let's say P.P. Longstocking, for example, we have information about the author, but there are also information about the characters in the book. So if we can extract those persons, we can link them to, for example, an article about P.P. Longstocking or Annika or Tom.
So you're building up some kind of knowledge graph or ontology of all these entities?
Yeah, so it could be. So the library has a catalog which is with linked data, so we can. There's no limitations to the depth of the information model. It can be super deep, so we can just enrich our collections. And we're going to start the material we're going to start with when trying to do that is the electronically collected newspapers, which are now have a very sort of shaky metadata collection. There's almost no metadata at all. So we can extract text and then we can look for entities and then we can link those to different information catalogs on Wikipedia or in our own system. So then you can, when you have an article, okay, so this is about Stefan Löfven and this and that person, and then you will have sort of who are those people also. So then you all of a sudden from going from just having a big black, bag of text that you don't know what's in there to have all the entities and linked to some kind of catalog. That would be a fantastic thing to do. Nice. So that will be combining the language model with linking to traditional library data. That's one thing. The other thing we're working on right now is Similarity. Interesting. So you can take a text from the library by some famous novelist like August Strindberg, for example, and then you can compare other texts to that. So you can have a scale of how Strindberg's are different authors, for example. Or
yes, text similarity is actually one of our specialties as Peltarion as well. And we did actually an author classification thing, so you can basically enter some text and see what kind of author is this most similar to. And
yeah, exactly. And or you can bring your own text. So I wrote this blog here about Swedish politics, which sort of editorial writer am I most alike? Well, it turns out you're most closest to Peter Wolodarski or whatever, you know. And then the users of the library can really create their own temporary metadata. So if you build a framework for that, they can bring their own text. They can take a text from the library and compare it to other text, and they sort of, oh, where is this text in this or that universe? You know, so.
Cool, very interesting stuff. And if someone would like to have more information about the work you're doing, how can they find that? Do they look you up personally?
Yeah, sure. And since we're very new, so we're among everything else that we do, we're also building our webpage right now, but we don't really have one. So we're under the library's webpage, and where we are completely invisible. So there's no information really online to what we do. There's a GitHub page where our language models are.
And what's the name of that if they want to Google that?
I can text you. I think it's Kung Bib or something. Yeah. If you search for Kungliga Biblioteket, it's a GitHub, you will find it. Other than that, can they talk to me? Yeah, well, so using the lab, since there are very many research projects now who wants to use the lab, we are getting much more requests for the lab than we can handle. So there's a formal onboarding process just to sort of.
It seems like Simon actually produced the link here for everyone. So
thank you. Perfect. Kung Bib, yeah, that's us.
And also a small question from Anna here. Yeah. How does actually Similarity works?
Well, so for any object, be it text, images, or whatever, in the end they can be represented using vectors or tensors or something. So you just look at the similarity between vectors. How much alike are they? If you turn them into zeros and ones, how much alike are them? And the more alike they are, you know, the better similarity they have. And you can do that in a traditional global vector space where every word has one identity vector among context vectors. So for the word tomten, the Swedish word tomten, there's only one vector, which can be confusing because tomten can also mean it can mean Santa Claus, or it can mean a strip of land. So you want to have, that's the cool thing with BERT, it has a vector for every instance of a word. So
I have a favorite example of trying to understand, you know, what BERT brought on top of like word2vec and glove and these traditional type of vectors that you have, or word embeddings that you had, which is if you take a sentence like Orlando Bloom met Paris Hilton, you understand that Paris in this context means basically the person Paris Hilton. But if you instead said Orlando Bloom checked into Hilton with Paris, then Hilton in Paris, sorry. Then Paris in this case actually means the city of Paris and not the actual person. And if you don't actually take the whole context, the whole sentence or words surrounding it into context, you can't really understand the difference. So we have a much higher understanding of the semantics of the words.
Yeah.
Thanks to BERT and these other things.
Yeah, and as we all knew, when we are using language in our everyday life, the same word can have very different meanings depending on the context. So, and that's what is being taken into account in there.
A practical example of that is when we're looking at our portfolio. What is an AI project? First of all, sometimes in an application they mention AI because they're distancing themselves or using it, but also the strength of the relationship is quite important for us, because sometimes they just mention it or use it very little. So it's important to understand also the strength of that relationship, I would say, at least for us.
Yeah, makes perfect sense.
So there was a question here from Sonia. Do we have cooperation with Clarin? Yes, we have close cooperation. I think our closest cooperative partner in Sweden is RISE and Språkbanken Text in Gothenburg, which is part of the Clarin network. When it comes to data, one of the reasons that the Swedish Language Bank, which is the Clarin node in Sweden, want to work with us is because we have data that is has more variety and it's larger corpora, etc. So yes, we work with Clarin and also with the Language Bank speech in KTH.
Cool. Thank you very much for that introduction. And as usual, if someone has more questions, just put them up on the chat and we'll try to get them answered for Lube or Daniel before. But let's move over to the last talk, and then we're going to hear about an example. Heard text classification from Lube, and we're going to hear about another type of text classification now. And this was one of the initial pieces of work that we did in this Swedish language model for Swedish authorities project, together with RISE and Vinnova and Arbetsförmedlingen and others. And we're going to hear more about it from Sebastian.
Right, so thank you. So we're going to do something a bit more applied. I hope everyone can see this. Cool. So we made a thing. We made the Swedish party classifier. We made a small front end for that thing, and we can now enter some text into the thing.
So what do you mean with the party classifier?
I'm exactly getting to that. Okay. So we can enter some text here, and this web application will try to predict which Swedish political party wrote the text. So it's a bit of a similar thing like the one you mentioned, Louis. So let's put something in, something not so controversial. Oh, I have the English layout. So we need to raise taxes, I claim, and the model says that that sounds very left-wing. Yeah, that makes sense. That makes sense to me. So let's try with the opposite example. Does this work? Yes, now it gives us some more of a right-wing prediction. So that makes sense. But this is not what's cool. What is cool is that we can actually translate this sentence to another language, English, for instance. So you see that I'm not lying. And we can classify this. And let me just flip between the tabs. And you see that the predictions are super similar. We can try a bit more of a, sorry?
Yeah, I'm just trying to clarify. So you took the same text in Swedish, you just translated that. You tried to predict what type of political party it was.
Exactly, what type of Swedish political party it was.
Even though you wrote it in English right now.
Exactly, exactly. And we could try with another language which is not even part of the same language family. So we'll do French.
If someone listening has a suggestion for another language that you would like us to experiment with, just write the name of the language and we'll try it out live and see if it works.
Thank you for throwing me under the bus, Anders. Love that.
Very good.
So we can see that it's not exactly the same, but it's still like, it could be worse as far as semantics goes. And now I'm going to move on before we get any suggestions.
I've tried this in Russian and whatnot, and it works surprisingly. Oh, Mandarin.
Mandarin. All right, let's do it again. Give it a go.
Just try it once, just for fun.
Yeah, absolutely. Does it do? No, it's this.
I think they call it Chinese.
I think it's Chinese as well. Yeah. I'm going to go with simplified because I'm a simple man.
If
so
this
let's
works,
see.
I would be impressed.
Yeah, that would be something, wouldn't it?
Hey,
yay!
It worked.
Yeah.
Right. Well, let's move on. So. That's amazing. Didn't move on fast enough. All right, so we are going to be talking about how we made this thing, this classifier, and what models we used to make it work across languages. So let me just flip over to the actual presentation. Well, at least the prediction was right. It just crashed as well. I guess that's the price we pay for Mandarin support. Okay, let's see if this works.
A small technical pause.
Rasky. All right, so this seems to be working. Well, we're going to be talking about multilingual NLP, but before we get into the details, I just want to touch on Peltarion and who we are. So Peltarion, we're on a mission to make these AI techniques available for everyone and not just the tech giants, which we have previously mentioned in the Chinese and the US context is pretty much dominating. And one major part of this is that we offer this Peltarion platform, which is a web service where you can train and deploy your deep learning models without having to bother with the GPUs and the orchestration and all that. We handle it for you. So we also have this research team, which me and John is a part of, where we do internal and external research projects. And we also help some companies get up to speed with these AI techniques that we offer. So just to mention, to make it a bit more concrete, what type of research we've done. A few examples is we've done brain tumor predictions using MRI images. We've done something completely different, which is predicting this wheat rust disease on crops in Ethiopia. So the idea there is that you can use these satellite images to try and figure out if this wheat rust disease is attacking the crops. And if it is, you can prune those plants, that is, if you can predict it, and make sure that it doesn't spread. And this will fight starvation, basically. So that's pretty cool. The fifth one is particularly interesting. It's predicting energy production of wind turbines. So you have to figure out the wind to be able to figure out the yield of the turbines, and to be able to figure out the wind, you need to figure out the weather, and predicting the weather is a super tricky problem. So that one is particularly interesting. So with that super brief note, we do a lot of varied stuff. I just want to hand it over to John, who's going to be talking about multilingual NLP. Did I break the thing?
I think John is taking over, right?
Yeah.
Oh, that's great. Excellent. It just takes a bit of time in between.
All right.
All right, brilliant.
Thank you, Sebastian. So let's just get straight into it. So we've seen a lot of great progress in NLP recently, most prominently starting with BERT in November 2018. And since then, we've seen a lot of progress. Roberta, ExcelNet, Albert, just to mention a few. But this progress has been mostly limited to English. So the pre-trained models that are released are almost always in English. The benchmark data sets we have, like the GLUE benchmark, is in English. But we care about a lot of other languages. For the seminar, we care mostly about Swedish, but we might also care about Norwegian or Somali or any other language. So what can we do about that? So as we saw from Kungliga Biblioteket, people are training BERT models in other languages. So there are German BERT models, Swedish BERT models, Dutch BERT models, and so forth. And a lot of great work is being done on this front. But is this the only way? Could there be some other way we can solve this problem of handling other languages?
Should we interrupt with a small question? They were missing Google's T5 model.
Yeah, I wasn't intending to list all of them.
There is so many different BERT-based models coming out. It's like 50 of them probably. So
the T5 is very cool. Yeah. It's a very cool model.
Yeah, it is.
In English, unfortunately.
You can try it on top to the transformer if you want to. It's kind of cool.
So are there other options? Could we have a single model that can handle all the languages we care about? That is the question. And in November last year, Facebook released XLMR, which is the state-of-the-art multilingual model. It is trained on 2.5 terabytes of common crawl text, and that is basically just text scraped from the internet in 100 different languages. And the way it is trained, so the model is basically just Roberta, for those who are familiar with it. And the way it is trained is by doing something called mask token prediction. So what you do is you have this huge corpus of text, you take out sentences from that, and you randomly mask or hide 15% of the words. You then feed those sentences through the model, and the job of the model is to try to predict which word should have been there in its place. So in this very simple example, I would enter my mask is John, and the model would probably predict that it should probably say name. My name is John. And this is basically all that XLMR is. It is fairly simple, but it is done on a massive scale. It's a big model trained on a lot of data.
So we got the more philosophical question here. If you want to try to answer it, Philip says that the model is just a bunch of numbers and doesn't really contain any information.
I think that's a response to Sheetal's
comment
previously.
Okay, I see. Okay.
That's complicated legal stuff, I think.
Yes.
There's no clear answer.
We'd prefer to interpret it as philosophical, though. The legal stuff is not as fun.
I like philosophical discussions, so I would love to.
You and me both.
That. Okay, sorry.
All right,
please continue.
Now that we know what the XLMR is, let's look at some results. So the task we are most interested in is, or the setting is what's called cross-lingual transfer. And that means that we train on one language and evaluate on a bunch of other languages. And the data set for this, one of the data sets for this is XMLI, which contains an English training set and an evaluation set in 14 other languages. So we train the model on English and evaluate it on the other languages. And here we can see the results. So it's compared to multilingual BERT and XLM and it's better than both of them, often quite significantly, especially in low resource languages. But the interesting thing here is that we see that on English we get 88% accuracy, and on average across all languages we get 80% accuracy. That's not a huge difference. So even though we haven't seen any other languages during this fine-tuning, it can still do fairly well. So we wanted to look at this a bit ourselves, so we grabbed a data set that is available in both English and Swedish that we have. And we began by training it on Swedish and evaluating it on Swedish, and then we got 85.7% accuracy. Then we tried doing cross-lingual transfer. So we trained it on the English dataset and evaluated it on the Swedish dataset. And when we did that, we got 84.4% accuracy. So that is not a big difference. So we could get this high accuracy without any Swedish training data, which is quite incredible. So what this means is that we can achieve good performance on the tasks we care about, even without any labeled data for training. Of course, we still might need it for evaluation, but we don't need as much for that. So you might ask, how is this possible? How can XLMR generalize across languages in this way? We decided to try to understand that, and we did that by sampling just 4 sentences from XNLI in 15 different languages. So the same sentences, but in many languages. We then fed those sentences through XLMR and looked at the internal representations of these sentences. Those are very high dimensional, so we used something called UMAP to reduce that so they can visualize it. And here we show the 10th layer. Where
so what's a layer in BERT?
So you feed a sentence, you have an input layer, and then it's successively transformed as you move through the transformer architecture, as it's called. And successively, it's going to involve more and more context and build a better representation of the input.
Yeah.
But in this visualization, the colors represent languages and the symbols represent different sentences. And we can see here that XLMR actually makes fairly clear clusters. So it understands that even though the text is in different languages, they are talking about the same things. And this means that it could potentially generalize very well, which we have seen. And note here that this is without us never telling XLMR how these languages are related or that words mean the same thing or anything like that. But just based on context and mass token prediction, it has learned this, which is incredible, I think.
So it's like it's building up its own internal language in the middle of BERT in some way?
Yeah, it's like it's creating some kind of, yeah. So you might ask now, like, what if we only care about one language? We only care about Swedish. We have a Swedish model, we have a Swedish data set. Why should we care about this? And I agree that in that case, you're probably well served by a Swedish model. But this is a fairly strong result that XLMR is actually competitive with monolingual models on monolingual tasks. So the GLUE benchmark is the standard benchmark for English NLP. And here we can see that XLMR actually outperforms English BERT on an English benchmark, even though it also handles 99 other languages, which is quite impressive. If we do a more apples-to-apples comparison, we would compare it to Roberta, and then we see that Roberta is indeed slightly better, but the difference isn't big at all. And note also that this is for English. We have a lot of English text, so it's not that surprising that the monolingual models are good. For a low research language, where we don't have as much data, it's possible, although we don't know at all because there's no way to evaluate, it's possible that the multilingual model could be better than the monolingual model. So let's just zoom out a bit and think about like the pros and cons of these multilingual models. And obviously, one big pro is that we can now handle many languages simultaneously. And if you're in some application where you actually have text in different languages, that's obviously very useful. Even if you only care about one language, this means that we don't need to train language-specific models. And for many languages, it's just not going to be practical to train models. For Swedish, we can do it, of course. But for many, it's not going to be possible due to the lack of data and so forth. And this is really the big point, I think, which is that we can achieve good performance even without any labeled data in our language. So say we want to do sentiment analysis in Swedish, and there is no data set for sentiment analysis in Swedish. what we can do is we can grab an English data set for that task, train on that, and then have a model that just works Swedish. And that's a pretty big deal because you can do it right now.
So we could do it for minority languages in Sweden, like meänkieli or...
Not sure about that. Probably not. I don't think those are included in XLMR.
No, exactly. So, because most languages that are included, there are language resources. So that's the sort of the paradox.
Oh, but some with more resources than others, of course.
True.
And the final pro I list here is that we could potentially achieve better performance in low research languages than monolingual models because it can generalize knowledge from, for example, English to other languages. Of course, all of these points are speculative because we don't really know because it's very hard to evaluate this. So we see we got a question. Does this work better for closely related languages? Yes, it seems to be that way, but it's not really clear. So if we look at the results from earlier, we saw that, for example, we did better in French than we did in Urdu. And whether that's due to lack of data or or the language being closely related, I'm not really sure, but it seems.
But it's reasonable to assume, like, if you have a similar vocabulary, at least it's easier than if it's completely different vocabulary, I guess.
That's fine. But of course, there are cons as well. So we might have worse performance than monolingual models. It's very hard to say. I would expect that could be the case for some of the languages where we have a lot of text data to train on. And then the final big downside is that XLMR is a pretty big model. It has more than 50% more parameters than BERT. And it's possible and likely that language-specific models could be smaller and more efficient. So if we don't need a model that can handle 100 languages, why should we use that? And with that, I hand it over to Sebastian again to look at the demo we showed you earlier.
Yes. So I'm not as quick as stealing back the screen.
Could we then, while we're waiting, ask Kungliga Biblioteket to actually do an Alberta training with multilingual setup, perhaps?
So the first multilingual model that we will build will be a Scandinavian model. So it will be Swedish, Danish, Norwegian. And I have such a long list of models I want to build, but that's where we're going to start. I was just asking about meänkieli because it's quite close to Finnish. So I was thinking maybe there's some general understanding of Finnish, what are they called, Finsk-Ugriska languages that could be perhaps transferred to meänkieli. Anyhow, so we're building that model, and we will try to get this as representative as possible. So we're working together with other national libraries in Norway and Denmark. And the Norwegians are really cool to work with, and the Danish, we're sort of trying to bring them in as well. But it's happening a lot now due to the coronavirus when it comes to copyright. So the copyright holders are being more and more liberal, and no one wants to be labeled the badass who's sitting on all the data when everyone needs it. So, we will try to, when it comes to Swedish, we'll try to sort of have as many variants of Swedish included as possible. So, from anything from doctoral dissertations to social media. Also, we will try to have a rich representation of what is called the Eastern Swedish, that is Swedish that is spoken and written in Finland.
What about more domain-specific one, like medical text? Do you consider having a special model for model specifically trained for that, or?
Yeah, the problem is text is. I think that will be something that perhaps will have to be a downstream model if it's not something really pressing. Because we're building sort of general models, and we think that other needs to train them for specific tasks. But I mean, yes, there are needs for models like that. So is there a medical model in the?
Yeah, we are part of that as well. So there's another Vinnova finance project for doing a medical language data lab as well.
Okay. So what will be the data?
So we are still just starting that project.
Okay.
But we are working with like Sahlgrenska and other medical institutions to try to gather data.
Okay.
For that.
So, but you're looking like, so it's going to be sensitive data, basically, like.
Yeah, so that's a big hurdle to begin with. So
Okay.
it's a lot of data safety issues and anonymization and how we handle that, and how to handle patient journal text.
Yes.
It's a lot of these kind of issues.
Yes.
Cool. Sebastian.
Right. So I hope you're all seeing this. So the idea is that I want to talk about how we made this model and the web app. And it all started out with us really wanting to try this XLMR model on a Swedish dataset, but like we have sort of iterated a couple of times now, there are not really that many Swedish datasets for actually evaluating the performance of models. And I guess the one thing I could add to that discussion, which hasn't already been said, is that you may have noticed the slide that John showed you previously with this size of the different corpuses used in training XLMR. You might have seen Swedish in 7th place, and that sounds pretty great, but it's actually unlabeled data, and you need some labels to actually be able to benchmark the performance between models. So it looks super great until you realize that. And it's not that much labeled data available at all, actually. So you have to get creative. Fortunately, the Swedish Parliament has this open database where all the documents are publicly available, and you can just go online and download them. So we did just that. We downloaded the motions. Motions is a document which a party writes when they want to sort of propose a change. They maybe they want to raise or lower taxes, for instance. So they write up a motion for that. So we collected all these motions from 2010 onward, which amounts to like around 32,000 motions, and that fit into 160 megabytes. So it's nowhere near the amount of data used to train XLMR. But you see that a lot of documents can be fit into just a tiny piece of memory when it comes to text. Right, so with all this data in hand, we went on our merry way of teaching the AI politics, because what could possibly go wrong with that?
You're trying to build a model that can understand the different Swedish political text? Or?
No, we want to thwart the government and replace Löfven. I thought that was clear by now. Okay. More formally, this is an author identification problem. So we want to answer the question, which party wrote this motion, basically. So it's a classification problem with 8 classes, since there are 8 parties. You know, give or take, we had to pick the ones that has been consistently around since 2010. Some might be missing. And note that this is an all Swedish corpus. The model was never exposed to any other languages during this training, and yes, we used the XLMR model. So we had to do some minor pre-processing before we could actually feed these motions to the model. In particular, we had to replace the party names with partiet, that is the party in Swedish, because it turns out that the parties really, really like to talk about themselves. So unless you mask this piece of information, the model can simply tally up dimensions of, say, Moderaterna and classify according to that. And we wanted the model to put a bit more emphasis on like the choice of words and structure of language, so we had to mask this out. We also split the motions into chunks of 1 to 4 sentences. One motion can be several pages long, and like we have mentioned, XLMR is a huge beast, so to fit all those documents in memory together with XLMR is tricky. So we chopped that up just to make it fit. So did the model actually learn politics by training on this task, trying to predict what party wrote which motion? I hope you can see this. It's large enough. So let me break this slide down to you. On your left, you have this confusion matrix, which has been mentioned previously, by the way. It shows what the model predicted versus what was actually the true label. So everything that lights up on the diagonal is a correct prediction, and everything off diagonal is a misclassification. But we can see which parties were confused with which using this. And on your right, you see this UMAP embedding. This is very similar to what John showed you previously, only this is representing our 2D sort of prediction of what the model sees, quote unquote, when it makes the classification. So what's interesting about this? Well, it turns out that if you look at the second row from the top, the M row, we can see that the M party is mostly confused with C, L, and KD. That's the blue parties and the deep green one. And this is fairly accurate as far as politics has been, like since 2010. These parties have been having the same or raise very similar concerns when it comes to politics. And I myself might have confused motions written by M for something written by KD, for instance. So we also see the third row from the bottom, the S party was mostly confused with MP and V. And these are also like the more typical left-wing parties as opposed to the previously mentioned right-wing parties. And it really defines it to sort of, historically at least, poles in Swedish politics, the groupings. So it looks like the model actually learned a sensible representation of Swedish politics just by training on this very simple task. And we never showed it any like lay of the land. It just tried to predict which motion position were which party, and it got these representations.
Have you shown the result for any politician?
We haven't really. We have a lot of people here around that want us to go and show this and wave this around. Depending on how you interpret that, it might be a good idea, might be a bad idea.
It would just be interesting to hear their view, or any researcher that is into this field, and see what's their view on this analysis.
I think they would be upset if they take their motion and it seems to be mostly another party that they are writing on, which they may not like.
But this is really cool. And if I see correctly, I forgot my glasses. So, but SD, you have the highest hit rate, right?
That is the yellow one. Yes, that one was the easiest one to predict. Yes.
Yeah, and that's also sort of according to expectations, right?
Yes, that one was consistently the more outlier of the ones.
Yeah.
So it really represented the view.
You see all these they do very fundamental statistical analysis of which is questionnaire based in the newspapers before every election. Who are you in the political landscape? Blah blah blah. This is way cooler and probably more accurate. I think
it's also interesting because it feeds into a discussion that was it last fall when they discussed, should environment and climate really be about party? Is it really left wing?
Right.
In practice, it turns out to be that, but it shouldn't. So this really highlights that and fuels that discussion.
Very interesting.
Yeah, no, it's super cool. We were really amazed when we saw this.
But I think it's interesting. Sorry if I talk about it. But it's interesting to put this stuff that the data scientists, I don't know your background, but data scientists do to put that in relation, as you mentioned, with social scientists, because there's a gap between here that we don't really bridge. So, because these are interesting results, and if someone were to tweak this or use this, they could really use it for some really cool research. But that rarely happens.
And I think that's interesting, and especially one of the other favorite areas that we have at Peltarion is explainable predictions and trying to understand why it predicts something to be a certain political party. And there are some techniques with NLP, but it's still very immature, I would say. But if you were to have more techniques to understand why it makes a certain prediction, I think then it would be much more useful as well for social sciences and different use cases, right?
Yeah.
But you can still get you can get the relationships out. You can get this sort of clustering, quote unquote. Like you can visualize that in a way that makes sense. The explanation or the need for explainability is not as large in those sort of groupings, maybe.
We have some questions here, perhaps as well.
No, maybe we should ask them.
First,
also, I'm sorry, Philip. The plot is cutting your right.
So Frederick is wondering if we try to extract the most informative word, or I guess relevant words per party.
We did not. We have not tried to do any, or I haven't. John, did you look into that?
No. But it sounds very interesting.
Yeah.
No, we were thinking about this though. Like you would probably, like a similar question is, how good would a bag of words model perform? Probably, like if you can just count very, very meaningful words, maybe that would show a similar thing. And maybe it's just like keywords based. Like, some politicians run with that policy, like that type of politics. They just regurgitate a couple of keywords. That seems to work out for them. So.
There are some problems, of course, that BERT is not like a single word kind of embedding, so it's hard to do this in a statistically correct way, so to speak.
That's one of the big problems for on the user end of those language models.
Exactly. But it's certainly possible somehow, but we need to think about how to do that the right way. So.
One of the layers is actually a global vector layer. Yeah. It's 19 in the standard BERT. Can I ask the question from Anna?
Please do.
Sentiment analysis. Yes, there are several models for that, but we're training. There's sort of pre-language models, NLP tunnels, which are SPARV, which is at the Language Bank in Gothenburg University, and we also have it now since we cooperate with them. We have their NLP. It's Swedish trained NLP tunnel, and we have it on the library as well. And it's sentiment analysis part of that tunnel. But we can also train the language models for doing that. It's not a big task. It's pretty straightforward.
I can also say that one of the goals and objectives for the Swedish language model project that we're speaking about is also to try to basically build up a catalog of the best data sets that we have to train these type of models. And we also have the Swedish language data lab project that also built up the Swedish named entity recognition model and things like that. So hopefully there will be some very easy to use kind of catalogs where we can find it so everyone can try to train them themselves.
Yeah, and fine-tuning the models is not that hard. It it does not require super expensive hardware to do that. So we encourage everyone to use the open language model and fine-tune them for different NLP tasks downstream. We hope that people do that and publish, of course.
Yeah.
Absolutely. So let's continue. So just to reiterate, we saw that the model actually learned a nice semantics about the politics, like in this vector space of it. And so let's just take a step back and think back to the demo, like we just saw, and the results that John showed previously as well. Like we have seen that the model has a sensible representation on a Swedish task, evaluated on Swedish, but we also saw that it sort of worked pretty well on other languages. So this also hints on this, that these models may carry the knowledge across languages. Like we have this semantic representation on one language, and maybe it's valid for another language as well. So this is very preliminary stuff, but it looks like this is very promising. Like we should look into this, and because it hints of this huge potential of multilingual NLP, which we have been mentioning like on and off. But I want to sort of summarize that. But if you have this massive multilingual corpus, which you can pre-train on, it looks like from this experiment, we saw that we could train on a Swedish task, on a solely Swedish data set, and get it to work on other languages. And we didn't even try, we just trained it like usually. We bet we can improve these results if we really take into account that we wanted to generalize. It's not super duper interesting to do this from Swedish, since there are not that many Swedish data sets around. But when you consider doing it from English, like John mentioned previously, things get really exciting because there is a lot of English data and a lot of NLP done in English. So if we can sort of piggyback on the English NLP progress and train models on that data and simply deploy them in Swedish, that would be amazing for this product. And it's something we really want to pursue.
We have a question from Frederick here that I'm sure you can answer, Sebastian.
Yes, I can. So that depends on, not to get too technical, but it depends on the context you want the model to have. So if you want it to carry a larger context, you can use or you need more memory per observation, like per sentence, if you will. We trained this on 2 GPUs, actually. In total, that was around 50 gigabytes of video RAM. So it's quite large. But then you could fit it into a much smaller GPU if you used smaller batch sizes. We had the batch size of around 100 or so. So the thing that really takes up the space is when you need to backpropagate your updates. But yeah,
but if you simplify it would be almost possible on a 16 gigabytes GPU, but then it's limit.
It's going to come smoke out of
batch size 1 or something.
Yeah, no, I don't think you can, honestly.
24 at least.
Yeah, 24 you can do 24, I think, but then your batch size has to be like 1 or 2 maybe. I'm not sure, actually. I know that
we have batch size like 70 or so.
But we have 48 gigs.
Yeah,
yes.
Exactly.
Yeah. So maybe we had 70, yeah, okay.
I think you should be able to do something with 16 gigabytes, but it's going to be slow because you're going to have a small batch size.
Yeah, it depends on the task. Like if you want to fine tune it, you might be okay with the smaller batch size. If you want to train it on, who knows, really? It's huge. The moral of the story is it's huge.
To pre-train it, you need a lot.
Yeah.
Facebook didn't even say how much they used, but they trained it for months.
Yeah, they trained it for months on Facebook level compute. So it's probably like the chart you showed previously. Yeah, it's something like that, but probably worse.
probably too scared to mention.
Yeah, I'm
because
having nightmares thinking about
calculate how many trees they had to cut down to do that.
Yeah, that is a huge problem.
But it shouldn't be impossible to gain access to the really big computational resources, because Swedish is online at least a pretty big language. So it's interesting so NVIDIA, for example, they have shown a lot of interest of Swedish data. So if you give them access to data, not to use the data per se, but to use model information coming out of the data, those are the kind of corporations that I would like us to see to sort of explore what can be sort of.
I can just mention the AI Innovation of Sweden efforts that have an NVIDIA GTX1. So we can do some training on that. And they have something in Luleå as well that we can make use of for these kind of use cases.
Yeah, but we should contact them directly.
NVIDIA,
I think they would be interested if they could get a hold on big Swedish data sets. That would be very informative for them.
We can perhaps mention the connection we have with Facebook as well. I'm not sure if you have that in a slide, but
no.
We can perhaps speak briefly about that as well. The XML.
So it was about these XMLI data sets. And I think John was the one sending emails, so maybe he would like to mention it. But it's about getting Swedish into that.
Yeah, so we thought about, so if you want to use these multilingual models for Swedish, it would be nice to have Swedish included in XMLI, so that people working on multilingual models also evaluate on Swedish.
Yes.
And we basically just contact Facebook and talk to them, and if we were to put in the effort to translate XMLI to Swedish, they would be happy to add it, which could be a huge boon for Swedish language.
Cool. It's this piggyback on others strategy, which seems to be really promising.
Getting Swedish into the most common kind of data sets and benchmark that we have out there would significantly improve the other researchers actually using Swedish.
Absolutely.
And it's a seal of legitimacy as well.
Yeah, a Swedish clue would be a huge...
Yes, it would be amazing.
So we got another question. Are these multilingual NLP models dependent on language families, or do they potentially work across different language families? So I'm not sure we know, but if we look at the benchmarks, we see that it works for languages in completely different families. But it seems likely to me, at least, that they're going to work better within a family than outside. But from the XMLI results, it still works well.
It depends on what you mean by depend on or by work in this sense. Like if you look at these cross-lingual transfer tasks, then probably the closer we think of the languages, it will work better if they're closely related, like language families. But if you think about like, does it work like at all? It does work. It doesn't really see languages in a way. So you can use any language that it has been pre-trained on, unless you want to pre-train it yourself, that is. But then maybe the transferring from a very esoteric language, seen from my Swedish mind, to another language, it might not work as well, but yeah, it will probably work to just train it on.
So in the visualization I showed earlier, we used XMLI, which contains 15 languages that are very different. So there's Chinese, there's Russian, there's English, and so forth. And we still saw that it could determine that they were talking about the same things.
Yeah.
So it works for sure.
Yeah. Cool. Right, so let me just conclude. We've seen that the XLMR is able to model the political landscape based on this motion prediction task, a very simple task. And while there is not much annotated Swedish data, we might be able to utilize these multilingual NLP models to get around that, by piggybacking on English, for instance. And that are, I think, the main takeaways from these experiments and this project that we did. So what are the potential future applications? We've heard a lot of them already, but like, who are we doing this for, really? What's the point? So we're doing this for Arbetsförmedlingen for one. This is the Swedish language model for authorities project. So from the name, you might guess. So if this project is successful, we will be able to, or the Arbetsförmedlingen will be able to match their applications much more effectively with their positions, for instance, and all the other document work they do will just be effectivized by a large margin. And maybe this will even be possible across languages if we go this route and we can try to deploy multilingual models. Who knows? We're also doing this for Skatteverket and Tillväxtverket, a couple of other authorities. Now, I don't know that much about their business, truth be told, but I know that they process great volumes of documents. Like we've heard, a lot of documents is being produced. And that just takes a lot of time. And AI systems can aid greatly in those tasks. Just filtering through huge amounts of data is done very well by machines. We know that for sure. And finally, we're doing this for everyone, really. Like the fruits of this labor are for everyone to reap when we have finished this project and the ecosystems are built, we have the models and the data sets. This is going to advance the AI of Swedish industry as a whole, just across the board, really. And that concludes this presentation. I would like to thank you. If you like to play around with this demo, you have the URL found here at the bottom. Put in whatever text you find enjoyable. It's all out of distribution probably, so we'll see how it works. Play around.
And please do reach out to us if you have any more questions and just feedback about what works and what doesn't work. Of course, this is an initial type of research work, but we'd love to get feedback about what works and doesn't.
Absolutely. Yeah. So you have our emails. If you like, you can go on this platform, .peltarion.com, and try and train your own NLP models. We have a BERT model up there if you'd like to try it. But other than that, I guess maybe there are some other questions. We have time for that, or you can send it to our emails.
So we had one question here from Philip, asking how it works when we put in the Chinese text. Like, how did it turn the Chinese characters into feature vectors? And the way it works is that the Chinese characters are simply a part of the vocabulary as usual when you would train a BERT model in Chinese. And so it's viewed like any other word in the vocabulary.
So they simply don't split into tokens in the same way as other like Latin languages are. It's basically every token becomes like a separate word.
Right now it uses something called byte pair encodings. So it sort of encodes on the byte level. As long as you can put it in memory, you can encode it, I guess. If that is something you want to look up, you can search for that, I think.
I see. I have a question from Sonia, who leads the Swedish Medical Data Lab project. So that is led by RISE, and other participants is Peltarion and Sahlgrenska. Sorry, it's actually led by Sahlgrenska Science Park. And then RISE and Peltarion is part of that as well, together with other medical institutions. And Vinnova is funding that, of course. So feel free to look up on ai.se. That's the homepage for AI innovation in Sweden. And you can find a link to that project and this Swedish language model project and a lot of other data lab projects that they help out with.
So I think there was another question from Gustav about XLMR being useful for translation. Did we answer that one?
No.
So I think that XLMR is not directly applicable to translation in that sense because it's just an encoder. There's no decoding part of it that would be needed to do the translation. Of course, you could do potentially similar things with a decoder as well, but that's not within the scope of XLMR, at least.
No, and when you train it, or when you pre-train it, you actually just feed the corpus as a whole. You just feed it with data, and you don't even tell it what sentence comes from what language. We just visualize that by putting in, we knew the sentences or the languages from the sentences, so we could color those up and put them in the model and plot those. But the model doesn't even see Finnish, Swedish, German. It just sees text or byte pair encoded text. So in that sense, it wouldn't even have a concept of translation, if that makes sense to you.
Cool. I'm going to start to round off now, but if you have more questions, just feel free to enter them. I'm going to, at the same time as speaking, which I'm really bad at doing, trying to create a last poll for everyone to answer. And I'm, let me see what I'm going to ask. Okay, I'm going to ask this question. What do you think about the technical level of the discussion? Was it too detailed? Was it not really clear or easy enough to actually understand? So please, what did you think about the level of technical details in the presentation? Too much or not? I have to excuse myself because I'm writing really slowly on a keyboard I've never basically used before. Too much, nice, balance, or the third option will be basically too little, too abstract. Cool, you should get, yes.
Alert windows.
That's nice.
It's been a while.
So please answer this last poll. And let's see, we had some more questions here. What? Can someone? Oh, here it is. Have you pushed your models to Hugging Face repo yet?
We have.
Oh, you have? Oh, really?
Everything's in Hugging Face and TensorFlow. I think we're 2 weeks behind on our GitHub and Hugging Face and TensorFlow, but everything will be there.
Okay.
I think that XLMR is also on Hugging Face.
Yeah.
Now.
Yeah. It wasn't us, but it's there.
Cool. It seems like most people think it was a nice balance, so great to hear. Even nicer to hear that some people want to have more technical details. That's usually the scary part, that you go far too technical in these kind of presentations. But great, then we can go in even deeper perhaps in the future.
Okay. Can we have another poll? We'd like to see LaTeX on the slides.
You want to see LaTeX?
No, but I think people want to do stuff now. I think we're in that stage. So people want to sort of have hands-on technical stuff. If I'm interpreting that as those answers.
And if you want to have like a super simple, just first test with this, and you're not really a technical person, then just Google for Peltarion BERT tutorial. We have a step-by-step instruction how to train your first BERT classifier on a different set of data sets. So that could be an easy way to get started if you're interested in learning more. Other than that, I think we can publish potentially the presentation that we did have, and we're happy to receive any more questions afterwards if you'd like to. We're also going to publish this presentation unless the participants here disagrees. So you can review it later and recommend it to other people. With that, I'd like to thank everyone for taking the time to come here and actually having an alternative for meetups in these kind of strange Corona times. Great to see so many questions. I really like that it was more of an interactive experience than I actually thought it would be. With that, thank you again. Have a nice evening and hope to hear from you soon.
Thank you.
Thank you.